Okay, this video is still chapter 14, and it's going to be dealing with ionic size. The first thing is we have to know what is an ion. So an ion is a charged particle, and it can either be a cation or it could be an anion. A cation is positive, an anion is negative. For example, calcium plus 2, and an anion would be like Cl minus 1. Generally, cations are made up of metals, or the left side of the periodic table, and generally anions are made up of nonmetals, or the right side of the periodic table. So we're going to first compare some cations. And when you're comparing cations, we can generally use the rules for atomic size. Increases to the left, increases going down, and the Y works. The explanations that we discussed before. But let's compare a couple cations. So if I have sodium plus 1, magnesium plus 2, and aluminum plus 3. So let me find those three. There they are. 1, 2, 3. So generally, I guess I could change this to ionic size since we have a new topic. Okay, sodium normally is 1s2, 2s2, 2p6, 3s1, but sodium ion is 1s2, 2s2, 2p6 because he lost his 3s1. Magnesium is also 1s2, 2s2, 2p6, but this one is in 3s2, but in order to become magnesium ion, it becomes 1s2, 2s2, 2p6. We seem to match. Let's look at aluminum. Aluminum neutral is 1s2, 2s2, 2p6, 3s2, 3p1. However, aluminum ion loses those last three to become 1s2, 2s2, 2p6. So we have a tie. The only difference is protons. So I'm going to look at number of protons. More protons. When you have a tie like this, equals smaller. So looking at that, aluminum has 13 protons, magnesium has 12, sodium has 11. That means aluminum is going to be smaller than magnesium, which is smaller than sodium. And that's how you'd rank it. You can just follow the arrows. Okay. Now the thing is, if you compare, let me show, cations to cations, that works. If you compare anions to anions, let's look at some anions. Let's do those three. Let's do nitrogen minus 3, oxygen minus 2, and fluorine minus 1. So looking at their electron configurations, nitrogen, just neutral, should be 1s2, 2s2, 2p3. But in order to become -3, he needs to gain 3 more electrons. So he will become 1s2, 2s2, 2p6. Same game for oxygen. I'm going to do the neutral electron configuration, 2p4. I'm going to add 2 electrons because now he has a -2 charge. And you're quickly seeing a pattern here. Just to make it complete, I'll finish out fluorine. And when fluorine gains an electron, the 2p5 turns into a 2p6. A tie. And I said when there's a tie in electron configurations, then we're going to look at protons. More protons equals smaller. So I look, fluorine has 9 protons, oxygen has 8, and nitrogen has 7, which means fluorine will be smaller than oxygen, which will be smaller than nitrogen. And that's how that's going to work. What if I mixed them? What if I had a mixture of several? So let's go ahead and mix them up. Let's look at, I'm trying to think this through, sorry. What if I compared fluoride, -1, bromide, -1, and sodium, +1. So I'm going to do sodium +1, fluoride -1, and a bromide -1. I forgot the R in bromide. There we go. So I'm just going to compare those 3. Well, the most important thing in size is energy levels. So I look, who's at the bottom? So let's look. Sodium is going to be 1s2, 2s2, 2p6, and then he's going to lose that electron, so it'll actually end with 2p6. Fluorine is going to do 1s2, 2s2, 2p5, but he's going to pick up an electron to become 2p6. And bromine is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. If I planned better, sorry guys. 3d10, 4p5, but with the extra electron, 5p6. So look at this. He has more energy levels. He's energy level 4, he's energy level 2, energy level 2. So just right off the bat, bromide's going to be bigger. He has to be bigger. He has more energy levels, and that's most important. All right, now I have a tie. And I have a mixture of cations and anions, so I have to think. No looking at the trend arrow. So thinking. I said, if there's a tie, look at the number of protons. More protons means smaller. Sodium has 11. Fluorine has 9. So sodium is going to be smaller than fluorine. And that's how you break that tie.